ready now?
Yeah.
Okay, so let's get started.
Yes.
So, like this week, we are going to discuss a paper revisiting the global workspace orchestrating the hierarchical organization of the human brain in English.
Yes.
And the reason why I've decided to do it in English is that, we heard that now Professor Now, now Tsuchiya, when he was in Kyoto University as an undergrad student, he had a private journal club with Ryota Kanai, who is an CEO, the president of Araya Inc. And that's for improving the English and also to familiarize the terminologies in the paper. So we'll just follow their style. And then, today we're gonna discuss this paper in English. Okay, so let's get started. So, and as usual, do you know any of these authors, like Gustavo Deco and Diego Vidaurre, and more Ken L. Kringelbach or something?
For me, I don't know anyone.
Okay, I have heard of Gustavo Deco, I think.
Yeah.
I am not sure what he is doing, but I think I have read some papers written by him. So maybe we can just Google what he's doing. Yeah. Gustavo Deco. Yes, I think he's, I don't know, maybe some information theory related work. Gustavo Deco. Computational neuroscience.
Oh, yeah.
Argentina and Italian professor and scientist. He's or maybe you can just check the Google Scholar.
So he studies computational brain science or something.
I think so. Computational neuroscience group and physics at the National University of Rosario. And his research interests include computational neuroscience, neuropsychology, psycholinguistics, biological networks, statistical formulation of neural networks, and chaos theory. Yeah, so I guess decoding stuff, dynamic brain from spiking neurons to neural masses and cortical fields, computational stuff. Yeah, I think that's the reason why I heard of his name, because he did some informational related information related study on brain, functional connectivity dynamics and modeling, blah blah blah. So that's the reason. But again, I don't know the details of his research. But okay, so that's the kind of the summary on the information of the authors. Sorry, because we do not know a lot about these authors, but we can talk about the content of the paper without knowing a lot about the authors. Yes. Okay. So and so next we are going to give you a bit of summary of this paper. So first of all, the reason why we picked up this paper is that And last week, we read a paper related to global neural workspace theory, right?
Yeah.
After that, we thought that maybe it's better to read papers something related to that theory in a series, and then kind of connect these theories to have like a global picture of the global neural workspace theory research. And then today we just picked up this research because the title includes the word global workspace. And we are, interested in consciousness. And if I understand correctly, the theory, global neural workspace theory, kind of suggests to framework to investigate consciousness, or gives a explanation of mechanism of consciousness. But I think in this paper specifically, they are not talking about consciousness. Rather, they are kind of focusing on the computation happening in the brain, specifically the hierarchical organization. Yes. Yeah. To be honest, I have not enough time to finish reading the whole paper, so I need to first check the note. Or if you can give the summary of this paper, yeah, you can just go first. I need to check the.
So the authors studied the simulating study. This study is the authors used the data from the
human connectome.
Human connectome data, and how to and they focused the resting state of the brain data of the resting state and the 7 executive function or task relevant brain activity. And they examined the relationship or connection between the brain regions and the connectivity, and they wanted to explain the connectivity between the like the sensory area and orchestrating area.
Okay, so I found my note.
Yes,
explain a summary of this paper, so I can maybe give you a summary. Just a brief, may not be concise, but So it has been known that the brain is hierarchically organized in terms of anatomy and also function. So the brain has some regions, each separated region, and then each region works as a module for some specific function. And then some area kind of organize or integrate these information from these separated area. So that's the kind of the hierarchical organization in the brain. And we know that brain has such kind of organization, but it's not clear how they organize, how such kind of organizations allows the brain to perform function or some specific behavior, right? And to understand that kind of organizations, it's very important to get a large number of data, or at least this paper says. And then to overcome that problem, and they utilizes the data from Human Connectome project. So basically, if I remember correctly, or that's a kind of a data repository or something that stores a lot of human brain activity data with different or various tasks. And then, yeah, that's the reason why they pick or use the Human Connectome project data. And then using the data, the authors specifically focus on the global New York space theory to explain the organization in the brain. So the theory basically says that then there is some workspace called global New York space that kind of first receive information from sensory areas, and then do some processing and then broadcast it again to the other area. So that's I think one type of organization or hierarchical organization in the brain. So that's the reason why these authors are focusing on the global New York space theory. So, but in the theory, or I think there are few studies supporting or the specifying the area, I mean the global workspace. So these studies try to identify such regions. So basically asking, okay, the theory saying that there is some workspace called global New York space, but where is it in the brain? That's the question asked in this paper. And to identify the regions, global New workspace, the authors again use the Human Connectome project data, and then kind of define how we can quantify or how we can identify the global workspace. So specifically, they kind of first they kind of define the functional rich graph, or
the rich graph,
that set of regions densely connected within the regions for integration. So okay, so as the first step of the identification, they first define a functional rich graph that is basically a network of brain regions. And then the regions or the areas within the graph, functional rich graph, are connected with each other within that regions very densely. And this is for processing some informations. But from like other sensory informations, I don't know how to, or maybe I can just read the definition of this. Functional rich graph is the region of, or is a set of regions densely connected within the regions for integration than other regions for receiving somewhat integrated information. So I think it means that first the network need to receive some information. So we need to, or the network should have some area receiving the information or process, or the area processing that kind of local informations. And then after that, the network should also have some areas that integrate such kind of sensory information. So they define the functional or functional rich graph, or identify the functional rich graph for each or for different tasks. So specifically in these studies, they've just used the 7 tasks. And then find the commonalities or the interception among these networks. And that might give you a clue, or that kind of again identify the core integrative regions within the network. So yes, so the intersection of functional rich graph is identified as a global workspace in this paper.
So I'd like to confirm my understanding that in this study, the authors want to see the core global workspace theory brain region or area, and the rich graph is a candidate of the global the core GNW in this study. The authors think, right?
I think I think first of all, the functional rich graph is a kind of concept that authors propose in this paper for identifying global workspace. So it's very similar concept, I guess, but somehow different. So sorry, what was the question? So, or does it answer the question, your question?
And also the authors want to know the full brain's connection activity for the global workspace. The full, and so the authors want to know the full brain activity. So they saw the resting state and the task state, and they saw the and they want to know the core GNW in the brain network.
I guess, or my understanding is that if we have something called global workspace, there should be present regardless of tasks. So they just collect data from different tasks and then build networks. And then using these the data from various tasks, if there is some like shared properties or shared network across tasks, we can say that, oh, this is the core or the global workspace suggested in the theory.
The authors said use the term common
shared, common
or shared something. And in this figure
About
figure one, the red big dot is right common or shared some shared one.
Yeah, so I think in figure 1D, it explains that we can first correct data from various tasks and then find the intersection of networks across tasks, including resting states. And then the networks at the center is, I think, for integrating the information across or integration to integrate information from different sensory input. And then the outer networks, like a branch network, is, I think, for different sensory information. Let's say for vision or for audition or something. And then the network at the center kind of integrate or connect these information from different modality, I think. That's the idea, I think. I guess. But I am not sure.
I see.
And then I think the core idea is that first we need to find some regions that send an information from one place to another. And also we need to find a region that receiving information from different areas. That is characterized by characterized by transfer entropy or directional transfer entropy or something.
It is an LDTE framework. They also used for analyzing.
And I think in figure 2, that information flow is visualized. And then see whether that's a kind of functional relations matched up with the structural hierarchy. So I think when they say functional hierarchy, it means that information flow from one place to another, including input, including receiving information from other areas, and also like sending the information one place to other place. That's a functional hierarchy. And then the structural hierarchy, and to be honest, I didn't have time to understand this part, but it says that this is from analysis or this is kind of try to visualize
mirroring, right? Mirroring.
Myelination.
Yes, it is interesting for me. So sensory area is in this study the G out. So it's more myelinite, and the G and EG in the other area is less myelinites.
Maybe if I read the method part or results part more deeply, maybe I can understand what's happening here, but I just didn't have time to understand this part. But I think the figure 2 try to says that the functional hierarchy and structural hierarchy in a sense matched up. So there are some relations between functional hierarchy and structural anatomical hierarchy.
but I don't know the detail. What is the Grasser parseration? The difference between the Grasser parseration and the DK80 parseration. Do you know?
I think this is kind of related to fMRI processing.
Yeah.
And I do not know detail of this because I have never like analyzed the
Yeah.
fMRI data, but like when you kind of label, or when you have a brain and you want to label each brain lesions,
Yeah.
you can try to like map one label to like actual brain areas.
Yeah.
And then this Glasser parseration and DK80 parseration is different way of like mapping.
Okay.
So by doing or
Yeah.
taking two different method or parcerations,
Yeah.
I think in this figure, they try to show that their result is kind of robust.
But the G-in, the data is by seeing it is a bit different between these methods. G out and G total is the same trend. The scatter plot, but in G in is a little different. The DK80 shows the flat, more flat, and than the Grasser method. So
yeah, in terms of the correlation, yeah. I agree that the Grasser parseration gives a bit higher correlation than DK80.
Yeah.
But if or I see, yeah. But
normally this data is right. It's normally we want to see this data is same, right?
Yes, or when I read the conclusion or the discussion part or the description of this figure, says that there are strong correlations between the functional hierarchy and structural hierarchy. Or when we use the information flow or output from one region to another. But the less correlation when we use the information flow as an receiving input from one area to another. So G in kind of shows the magnitude or the strength of the area or receiving information from other area, but the region of interest or areas of interest. But on the other hand, the G out try to visualize the areas or the strengths of information output function in that area. And I don't know about the G like total. Maybe it's just the sum. Or
sum. It is sum
between them. So,
but it is not important point in this study.
I guess so. Basically, I think basically what they try to identify is, again,
Yeah.
which region receiving more input from other areas, and
Yeah.
also which regions sending information or sending output
Yeah.
to other regions. That's
So,
what they try to identify
yeah, I
first.
see. Yeah, I see.
And then again, in figure 2, they just shows that kind of, or their method kind of matched up with the function, anatomical structure hierarchy.
Yeah.
That's the point, I think.
Yeah.
And yeah, we can maybe go to the next
Yeah. And
figure.
also, oh yeah,
Figure, or yeah, you can go.
for me, it's, the figure 3 is interesting for me. And I think the authors want to say that G out is almost same the, between task and like little resting state. And the G1, G in is the different trend between tasks. I think they also want to say. And also the big, the larger difference between the task and the resting state. This is so small correspondence. And G total is the addition between G in and G out. So I think the G in's effect is more bigger than the G out. So the G total is the same as the G in, I think. But the relations between the tasks is more, how to say, calm, or G in is so different, but G out is same way. So G total is mildness by G out.
Yeah, I think, yeah. Now I found the summary or the note of this figure 3, and then basically I'm saying the same thing. So the areas receiving more information are different across tasks. And also that's corresponding to G in. So G in, yeah, incoming, I think. And the next thing is that areas outputting more information are consistent across tasks. So this part, to be honest, I am not sure. Well, I have a question, because like I did not know the detail of the task itself. But if we assume that like a different sensory input are given to subject, let's say in one task, the stimuli were say like a visual stimuli. Then the output area should be located around the B1 or B2 or visual areas. On the other hand, if in another task, if they use some like auditory stimuli, then it will be related to some like temporal or audition areas. So in that sense, the areas outputting information should be different across tasks. That was my kind of like expectation before like going into the detail. But if we look at the label of each task, it says like emotion, gambling, language, motor, relational, social, and WM. I don't know what it is. Maybe I don't know.
Working memory
and rest. Maybe in terms of the, the modalities across all the stimuli
Yeah.
across these tasks. They are just basically the same, maybe.
Yeah, I see. So I also wondering that in this data there is no brain area and how to say integrated to brain area, right? So you have a question, right?
Yeah, or like so I also didn't understand why the area receiving more or information are different across tasks.
Yeah.
Information. Yeah, because like if what global workspace theory suggests is true, then there's some like a shared area that always receive the information.
Yeah.
And then these areas kind of connected with each others, and then process the received information.
So I see, but in these figures, and they use the brain area is like higher hierarchy is higher region or something. I think so, because it is important for GNW that the information is shared or the brain area. So it means that it is not the first and second or lower order area, but I think this data shows the higher area, hierarchical area, and this, and I'm also wondering this data is the same as the how to say rich graph or not?
Functional rich graph.
Yeah. So this data in the figure 3 is the same as the this data is a total brain's activity integrated. And next they examine the relationship between the brain active rich graph and the seven task and resting activity.
I think they are just using the same data across this paper.
Yeah.
And then just explaining their process step by step.
Yeah.
So first identifying kind of some areas
where
receiving more input and also outputting or sending more input.
Yeah.
And then after identifying such kind of areas, then by have some assumptions, they identified all the areas like sending or receiving some informations across all the tasks.
Yes.
And then that is, I think, shown in figure 4. So yes, I think figure 4B specifically visualizing the intersect of functional rich graph. Yeah. And that's what I think that's what assumes as a global workspace. And I think this figure is kind of interesting in a sense that the global workspace theory,
Yeah.
if I remember correctly, say that like prefrontal and parietal
Yes,
area
yes, yeah.
is the kind of the very important or the core or the candidate
Yeah.
of the global workspace.
Yeah.
But this figures says that the frontal area is not the global workspace, but only the, I think the parietal area, so the middle of the brain is the global workspace based on their analysis. So that's a kind of different from the theory itself. But maybe I'm wrong. Or do you remember whether the theory or Duan include the prefrontal as the core of the global workspace, or?
But I think they didn't say the core is the prefrontal. But global ignition is important according to him. So,
but what about the areas? So did they mention that where is the?
yes, I. But the prefrontal is needed for global ignition.
Okay.
So the cohort or something, the researchers integrated and said the GNW supports the prefrontal or prefrontal, and IIT or something, recurrent processing is supports the posterior.
But like in the sense, this analysis says that the parietal is the important for integrating information, and that's, I think, do not contradict what IT suggests, and also maybe as the global neural workspace suggests as well, because the global neural workspace theory also says that the parietal is important for integrating information. So in a sense, like this shows that yes, the parietal is somehow like a integrating, or the it's just a global workspace.
Yeah, I see. So I think that the parietal area is also the integration of the sensory information, and so G in is high, and also the project the prefrontal or something other area. So G out is also high. So according to this analysis method, the parietal area is much more high activity, so parietal area is high.
So you mean the parietal should be more highly likely to be considered as
indeed
global workspace rather than the frontal or prefrontal area?
According to this method. But I don't know. I don't know the prefrontal area is not needed or something. I'm wondering I think this data cannot show that the prefrontal is not needed. But parietal area is important, and the result showed. But I don't know, the prefrontal area is not needed.
Yeah, what they are saying is that it's just the parietal area is, or the candidate, or according to their analysis, is the global workspace. And they did not mention anything about the prefrontal.
Yeah, I think.
or the importance of prefrontal, I think.
Yeah.
And also like what I kind of interested or found interesting is that
Yeah.
we kind of mentions the different set of areas, just one word. I mean, as parietals.
Yeah.
But they specifically list the different brain regions as a global workspace, like precuneus and nucleus accumbens, posterior cingulate putamen. Hippocampus, amygdala, blah, blah, blah. And then in the discussion part, they listed or they provide the literature saying that each area somehow related to some function listed in the theory, global workspace theories.
Yeah.
So for example, let's say the theory, the global workspace, neural workspace theory says that the integration of information from past and present and future is important.
Yeah.
And that can be done in like somewhere isthmus, I don't know, the cingulate and also like a hippocampus, the memory for the memory, and also like some other like functions. I forgot that. Integration of past memory can be or done by hippocampus, and then integration of past, present, future can be done. The precuneus, posterior, and isthmus cingulate cortices. Sorry, I do not how to pronounce this. Isthmus, I can.
Yeah, so it is interesting for me also too. But so these, this is a candidate of the rich graph in this study. So you said the brain area. You said
this is the global workspace. So intersection of F also functional graph.
So I think they include the brain, so basal ganglia and the limbic system. It is interesting for me because normally in this context for global neural workspace theory or conscious experience, normally the cortex is debated, but the basal ganglia is normally I've not so read or I've not here. They are important for global neural workspace theory or something. So it is interesting and new point for me.
I see, but like it has been like, or a lot of researchers says that like thalamus or the interaction between thalamus and the cortex is very important for consciousness or something. So or are you sure that the global neural space theory or the John says that the thalamus is not important for the global workspace, or? Again, I have not read all the detail, or I just do not follow the theories at all. So maybe it's better to do it like after this and then coming back to this for the understanding. By the way, anyway, like we can go to the last speakers. And this is basically like a simulation work to confirm that what they found is really important or doing some important function for orchestrating or integration of information. So what they do is that based on their empirical data,
Yeah.
they kind of model the networks,
Yeah,
I
yeah.
guess, and then kind of perturb the network or simulated model, or what they say is lesioning, I think, and then try to see the effect of lesionings. So
Yeah.
how that corrupts the functions
Yeah, yeah,
in the
yeah.
networks.
Yeah.
Then they says that, oh, if we like perturb what they called functional rich graph or global workspace, they just, or the network just lose the functions, or the orchestrating functions or integration functions, I guess. On the other hand, when they perturb or like disturb or destroy the connectivities
Yeah.
out of the global workspace, the result do not change, or it change actually, but like less affected than or less affected when they perturb the global workspace or functional rich graph. This is just a confirmation of their findings. Not, yeah, but like I think that's all of this like paper. So first, they says that then they want to study the hierarchical organization of brain.
Yeah.
And then they says that there is an obstacle or difficulties to study the hierarchical organization.
Yeah.
And they overcome, or to overcome the difficulties, they just use the Human Connectome project data.
Yeah.
And then given such data, they specifically focus on the global neural workspace theories, which propose kind of like networks or the connection of each regions. Then they evaluated that kind of networks, or kind of estimate that kind of networks based on the Human Connectome data, and then try to identify the global workspace, which is the kind of core of the networks that's receiving input, and then doing some extra analysis. And then finally, after finding or identifying that kind of global workspace, they confirm that their findings is that like true by like a simulation work, or lesioning the model, or systematical lesioning. And that's, I think, all about this papers. I think I pretty much raise the question I had. So like in this paper, the parietal area is suggested as the global workspace, but the prefrontal area is not identified based on their analysis. So I just wondered whether like, is it okay as in like a global workspace theory people, or for like those who support the theories? That's one thing. And also, I was a bit I was wondering, okay, when they use like a stimuli from completely different modalities, such as using visual stimuli or auditory stimuli, or maybe tactile and so on, will it change the results? Or I guess the at least the functional hierarchy map will change because the different brain regions kind of encode different sensory informations. Again, the visual information will be first like signal to B1 and then B2 and blah, blah, blah.
Yeah.
And that's different from auditory areas and also somatosensory areas.
Yeah.
But I don't see that they test that kind of hypothesis in this studies. And they're saying that the area sending informations is consistent across tasks. But probably when they say outputting information, it means that not only from one area to another, but rather one area to any possible all areas. And that's the same for the incoming incoming information. So when you say that one area receiving information, it does not mean receiving information from only one area, but from all areas. Maybe that's kind of clear my or answer the question. If I remember correctly, they said that the G in and G out is the summation of information flow across all regions or something. And if they do that kind of analysis, then maybe saying like when you present like visual stimuli, the B1, of course B1 send some information to other areas, but not to all regions.
Yes.
So the information like a flow or the intensity or magnitude of the information or flow is not that strong.
Small. Okay, I see. So, and for me, you said what you said that the parietal area is important and frontal area is not. I think for me it is. For me, I understand or I agree your idea, and according to the theories that the V1 or first order sensory area is not the NCC, and the higher sensory area and it means it shows the parietal area is important for sensory anything, perceptual consciousness. NCC of perceptual is the parietal area is important. I think that, and also the frontal area is frontal area is yes, for report or something action or something future planning is in the prefrontal area. So I think it also the frontal area is task relevant, more movement or response by voice or decision making and a lot of things. So this analysis is 7 tasks is integrated. So the the frontal area's activity is different, respectively. So after the integration, the prefrontal area's activity is
diminish or
diminish
or like just decrease or vanish or something.
Yeah, and also I think this strategy is good for like the core or pure NCC.
Yeah, I'm kind of suspicious about it because I haven't read the like task instruction parts, so I'm not sure whether they ask subject to do or to report verbally or like using button press or so that kind of your kind of understanding or the idea might work, but again I would say that if you ask subject to report your like subjective experience, if I understand or correctly or I think there are only a few options like verbal report or like button press, motor, and also just writing. And that's it. So I just not sure whether like that kind of small variety will like diminish the activity in the prefrontal.
But I think the complexity of the task or difficulty of the task is also affect the cortex, frontal cortex activity. So also the difficulty of the task is also the variation of the frontal activity, I think. Response pattern and the difficulty or complexity of the task.
Yeah, I think again the aim of this work or this paper is to identify some kind of region that matched up with the global workspace, specifically focusing on the hierarchical order organizations of the processings. And they do not talk about anything about the consciousness or perception or something like that. So maybe we cannot go that direct. We can't. We just can't talk about that kind of like a.
I agree. I agree with you. Yes. So in this study, the authors showed the parietal area is the role of the integrating information and orchestrating the information. And you know that this study is not for the conscious experience or access, and I think the global work GNW is for the access consciousness theory. So I think if the experience, if you focus on the subjectivity or accessibility, how to say, the discussion or the result is something different, or interpretation is, I think, different. This study is just shows just the So the information process and connectivity, and not the consciousness for not show the consciousness, the relationship between the consciousness and the brain connectivity. But it is interesting.
Yeah, like it's kind of interesting. I also I would like to understand the detail of their methods, so how they capture the information flow in their framework. So yeah, I would say I will. Yeah, I'd say read this paper after this discussion. I just thought
detail method area.
Yeah,
section.
Method. Yeah, I think do you have any questions or comments, or do you have anything to say?
I talked about no, sorry.
Nothing.
I discussed nothing. No,
Okay.
nothing.
Okay, then that's all from us.
Yeah,
we are very sorry that we are very poor at English, and also
sorry.
And I think this paper is maybe a bit difficult for us to understand in just for 100 minutes. So but anyway, that's all about it. Thank you for listening.
Yeah, thank you.
Okay, that's it.